Hello everyone, this is Math Hands-On with Python and welcome to the tutorial session where we are going to learn on how we can solve the LP problem with Python. So I have the illustrative example and we are going to use this example to see how we can solve the LP problems and determine the optimal solution, and also how we can determine the slack for each variable, determine the shadow or dual places, and perform the sensitivity analysis. So this is what we are going to see into our today's tutorial. Now let's start solving this problem using the Python. Now we have our Spider IDE environment here, and I'm saving my file as LP solution into the file called the solution LP. So other results, especially the sensitivity analysis report, will look from this file because we will store the file in this file. So let's go back to our Spider environment. To start with, you need to import the modeler function, and our modeler function is Pulp. Okay, so we import Pulp, and another library which I'm going to use is the pandas. So I have to import the pandas. Okay, after importing the panda library, the first step is to create a model or a problem for the LP problem that we are having. So we are going to do that by using the function LP problem. So I have created this model problem here. So my problem, I give the name as model equal to p.lp problem. This p stands for Pulp because I have imported Pulp as p. So whenever I use the functions from the Pulp, I have to use this p.lp problem. So I labeled it as my problem, and this one is the nature of the LP problem, whether it's maximization or minimization. So if you check to the right hand side of your screen, our problem is about maximization. Okay, so we give the name in the LP problem function. So we name the or we write the name of the LP problem, and we write the nature of the LP problem, whether it's maximization or minimization. So because the problem is about maximization, we write p.lp maximize. So after this, the next step is to create the model variables. Let's zoom in a little bit. Okay, so I'm going to create the model variables first. So you see the model variables are x 1 up to 3. So I have to create so that the model will read this variable or will recognize this variable which I'm going to create. So these are the model variables. So after creating these model variables, then I have to restrict or write the range of this variable. So basically I'm restricting my variables to range or to start from lower boundary, which is 0 to infinity. So these variables have a lower boundary equal to 0. So once you are done with the creation of the variables, then we are ready now to write the objective function, and this objective function we are going to write it and add it to the model which we have defined, or the problem which we have defined or created here. So we are going to start with writing the objective function of our problem. So we have the objective function here, and after objective function, remember we write the expression to the right hand side of the maximization function, which is 2 times x1 plus x2 plus x3, and we add this expression to the model which we created here. So we add this expression to this model so that it can be compiled and recognized it as one problem. So after having the objective function, then let's write the constraints of our problem. So this is our constraints or model constraint. So after having this model constraint, now we have everything, the objective function and the model constraints. Now we are in a position to solve the problem, okay? So what I want to insist, whenever you write your constraints, then make sure you add it to the model. The word model here is the name of the model problem that I created. You can give any name. So if you, let's say you give the name of your model problem as prob or problem, then this should reflect the name of the model problem that you have labeled. So this should be problem, because I labeled my problem as model. Then after writing the objective function, I have to add to the model created. Also, this constraint, after writing it, you have to add it to the model that you created. So now, after this, now let's solve the problem. So we solve the model or our problem, which we labeled as model, by writing model.solve, and then once this problem is solved, first we need to know the status of the problem. Is the solution optimal or not? So we are going to command the print out of the status of the solution, whether it's optimal or not, the optimized value of the objective function, the optimal solution for the decision variables and their respective reduced cost, and the shadow or dual prices and the slacks. So to do that, let's see the command to print out the solution of our LP model. So these are the commands for the solution of our LP model, and you can see here, let's zoom out, okay, and you can see here we have the print for the model status. These are the commands for model status, and we have the print out command for the objective value coefficient, and the third command is for the print out of the variable coefficients or the optimal variable coefficients with their respective reduced cost, and the fourth command is the print out for the shadow price or the dual price and the slacks. So after this command, okay, now you can run this problem and see the output of the solver. If you run this one, we are going to have the output here. So we have this output here. So this output basically, as we commanded, the first output is the status of the solution. So the solution is optimal, and the optimal objective function value is 60, and these are the coefficients for the optimal solution of this variable x1 up to x3 and their respective reduced cost. Also, we have the shadow price and the slacks for each constraint. So this is how you can solve the LP problem. Now remember, one part of this tutorial is the sensitivity report or the sensitivity analysis report. So the sensitivity analysis report, basically we have to add here into a solver function the specified function or solver which can create the sensitivity report. Okay, so I'm going to use the GLPK function or the GLPK solver to create the sensitivity analysis for our problem. So this is the GLPK function or solver, which I command this from Pulp, and I would like to solve for the problem and give me the output for the sensitivity analysis report. So the solver GLPK specifies the option ranges sensitivity 1.sense. Okay, that is the GLPK will generate the sensitivity analysis report into the file called the sensitivity sense, and this file basically will be saved into the file which I saved my Python file for this problem. Okay, so now we have to add something else here. If we would like also this model problem to be saved into a separate file, now we are going to do that by the command model.write_lp. Inside this function, you write the name of the file .lp. That means it's going to create a file and will be saved into the file where we saved our Python file for this coding. So this my problem file .lp is going to be created in that folder, and also the sensitivity report using the glpk will be saved with the name sensitivity1.sense. So let's run this one and see our sensitivity report. So it's done, and let's go to our file and see these are our two files report, one for the LP problem or model, and the second one is for the sensitivity report. So opening this by let's open it by Notepad. So open that by Notepad. You'll see the sensitivity report. So this is the sensitivity report generated by the glpk function. So thank you for watching, and this is the end of our tutorial on how you can solve the LP problem and generate a sensitivity analysis report. Thank you and goodbye.